Welcome to section 8.2, Reflections and Symmetry. What you'll learn in section 8.2, to graph reflections in the coordinate plane and to identify lines of symmetry. New vocabulary in this section: reflection, line of reflection, reflectional symmetry, and line of symmetry. And a check of the skills you'll need to be successful in this section. Number 1. Vocabulary review. A translation moves each point in a figure the same blank in the same direction. Graph the point A, 2, 4, and its image after the given translation. Why learn this? Reflections appear everywhere in the world around us. You can see reflections in a mirror or a pool of water, or in shapes, in art and nature. A reflection is a transformation that flips a figure over a line. This line is the line of reflection. Like translations, reflections change the position of a figure, but not its size or shape. In the diagram at the left, C and C prime are the same distance from the line of reflection. The segment connecting C and C prime is perpendicular to the line of reflection, the y-axis. And our first example problem in this section, graphing reflections of a point. Graph the point A at 3, 2, then graph its image after it is reflected over the x-axis. Name the coordinates of A prime. So the work is already shown in the example, but I'm going to use what they've given us and then go about doing the work myself, maybe over the top of their work. So first, it says to graph the point A at 3, 2. We move to the right 1, 2, 3 units and up 2 units and plot the point. So label that the point A. It's already labeled, but I'll label it as well. Then graph its image after being reflected over the x-axis. So now we need to imagine the x-axis. And remember, the horizontal axis is the x-axis. If you forget that, it is clearly labeled. And now we imagine reflecting the point A over the x-axis. I often like to say, imagine the ink that I used to plot the point A is still wet. And then we fold our coordinate plane across the line of reflection. In this case, the x-axis. So imagine folding the plot or the coordinate plane right at the x-axis, and then simply imagine, where would that wet ink leave another dot? The point where it would leave another dot is our reflected point, in this case, A prime. Now we can be more careful, and we should be more careful, and actually count. Well, A is 1, 2 units above our line of reflection, so A prime must be the inverse of that, or the opposite, so down 2 units. So therefore the coordinates we were asked to find of A prime are, from the origin, that's right 3 and down 2. So the coordinates of A prime are to the right 3, down 2, 3, negative 2. Now it's time for a quick check. Graph the point D, negative 2, 1, then graph its image after it's reflected over the y-axis. Name the coordinates of D prime. A vocabulary tip for this section: congruent figures have the same shape and size. When you reflect a figure over a line, the image is congruent to the original figure. So if we reflect a point over a line, we get a point. If we reflect a line segment over a line, we get a line segment of equal length. They'll be congruent. If we reflect a triangle over a line, we will get a post image, a new triangle, that is congruent to the original triangle. Here's an example. Graph triangle BCD and its image after it's reflected over the line through 1, 3, and 1, 0. Name the coordinates of the vertices of triangle B', C', D'. Well, at first glance, this problem may seem quite a bit more complicated than example problem 1, but it's not. One thing that makes it seem so much more complicated are the presence of 3 points, B, C, and D, and a triangle, and pair that with the idea that we aren't just reflecting across the y-axis or the x-axis, which are 2 lines already given to us in the graph, but now we're reflecting across a new line that's been defined for us as the line that goes through the points 1, 3, and 1, 0. So perhaps the first step we should complete is to graph the triangle, B, C, D. And there we can see it at the left in black, our pre-image. Remember, that's our pre-translation image. Then a great second step would be to plot the line that we'll be reflecting across. And we can plot that line by first plotting the 2 points that we know define that line. Remember, any 2 points define a line. So we plot the points 1, 3 and 1, 0 and carefully construct the line that goes through those points. Now the work begins to speed up. We consider our 3 vertices. Perhaps we should consider C first. It seems the most accessible in this problem. And we consider, well, let's ink dot the point C and imagine reflecting or folding this paper right at this fuchsia or pink colored line. That ink dot would end up 1, 2, 1, 2. We know the point C prime's already given to us, but imagine if it weren't. Here's where the ink dot would arrive or show up. So that would be our point C prime. Similarly, point B is 1, 2, 3, 4, 5 units from our line of reflection. So we would continue another 5 units, 1, 2, 3, 4, 5, to find the corresponding point to B, B prime. And we'll do something similar with D to find D prime. Our directions ask us to name the coordinates of the vertices B prime, C prime, and D prime. Our vertices are, C prime is at the point 1, 2, 3. Be very careful with units. 3, comma, 1, 2, 3, 4, 5. So 3, 5. And there it's labeled for us. B prime, 6, comma, 2, 3, 4. 6, 4 represents B prime. And finally D prime, 4, 1. Very good. And a quick check opportunity, number 2. Triangle EFG has vertices E at the point 4, 3, F at the point 3, 1, and G at the point 1, 2. Graph triangle EFG and its image after it is reflected over the x-axis. Name the coordinates of the vertices, remember that will be all 3 vertices, of the triangle E prime, F prime, G prime. If a figure can be reflected over a line so that the reflected image matches the original figure, then the figure has reflectional symmetry. The line that divides the figure into mirror images is called a line of symmetry. Many shapes in nature have reflectional symmetry. Many shapes in nature have reflectional symmetry. Try to consider a shape you know that has reflectional symmetry. Perhaps look around the room or think of shapes in nature. And you may not use a leaf or a snowflake. That would be cheating at this point. Okay, let's move on. In the leaf at the left, the black line approximates a line of symmetry. Snowflakes, of course, are a prime example. We talk about the symmetry of snowflakes, and that can also be exemplified as we cut out paper snowflakes. Example problem 3. Identifying lines of symmetry. Draw the lines of symmetry for the snowflake below. Notice there are 6 ways to fold the figure so both halves match. The figure has 6 lines of symmetry. Perhaps a good way to think about lines of symmetry is to imagine any lines across which you could fold the figure, and I'll be approximate here, but where they would match up. Again, imagine if this were wet ink, can we fold across that red line segment I've drawn and have everything match up perfectly? Well, with a little bit of imagination about my line placement, yes, we can. Something similar occurs here, here, but what about in between? Now, to finish this up and count, ooh, that one simply won't do. If we count each of these line segments I've drawn, but lines of symmetry, we'll find that we have 6 lines of symmetry, and you can see a better example here to the right of more perfectly drawn lines of symmetry. But there are 6. So check out the quick check problem. Number 3. Copy the flag at the right. Draw the lines of symmetry. And your check your understanding problems for this section. You may pause now if you'd like to do your work from the screen. You may also screenshot. Keep in mind you have many options. Work carefully, and good luck.